Hello everyone. So now we are learning VPN, virtual private network, right? So basically in the previous session we learned the basic concept, what is VPN, right? After that one we learned some symmetric algorithm, asymmetric algorithm, Diffie-Hellman key exchange, shared secret key. So these the things we just covered in the previous session. Now in the today's session I'm going to cover the first thing, that is what is IPSec, and most of the topics of IPSec I have covered in the previous session, but I will just tell what is IPSec, and whatever the remaining I will discuss that part. After IPSec I'm going to discuss phase 1, phase 2 of the tunnel formation whenever we are having the VPN and forming the tunnels. So there we normally are having the two phases, phase 1 and phase 2. So I will discuss how these phases are formed, what are the mechanism behind that one, and what are the messages are shared in the main mode and the aggressive mode, right? After that one we will see some of the interview questions, that what are highly being asked in the interviews regarding VPN. So after that one, first we will learn the concept and then we will focus on the interview questions, that how breaking the concept they are asking the questions, and how the interviewer can confuse you and ask the questions. Okay, so let's focus on the slide what I have with me. So let me clear this and choose some other color. I think this one should be fine. Blue color, perfect. So in encryption we talked about the DH key, right? Shared secret key, that is SSK we call it as. So these two are basically part of the encryption. If we talk about the authentication, in the authentication normally we do hashing, and the hashing we use that MD5 or any other SHA or something, whatever we want, we can use that hashing algorithm or techniques for that purpose. And protection we can have PSK or something, pre-shared key, that what we are doing. Or these some of the times these guys are just confused, or not confused, in fact they interchange the concept like protection and authentication. Some of the guys refer this authentication is normally what is that pre-shared key, that we are setting the password, that you can say. Or another thing, that it is authenticated, that authenticated message is coming, so then we are using the MD5. So but the concept is we are having the DH key, that encryption, hashing we are having, and then we are having the concept of PSK, right? So these are the three things which are going to happen the IPSec. But in order to work these algorithm and things, we are having in picture negotiations protocols, that based on which protocol these things are going to work, or they are going to share with each other. So in this negotiation protocol we are having two protocols. The first one is AH, another one is ESP. AH is now obsolete, and almost nobody is using that AH, and right now we are using ESP. ESP stands for encapsulation security payload. So this is then highly used, the ESP. So we will learn more about the ESP, in fact the mode of communication of the ESP. So basically there are two modes of communication of ESP. The first one is the transport mode, and another one is tunnel mode. So in the transport mode and tunnel mode, let's focus one by one. Okay, so this is our transport mode and this is the tunnel mode. So let's try to understand that what is the difference between these two. let's say this is our original packet, not let's say, in fact it is like that one. We are having the data, and above that data we are having the IP header, right? So that data is basically, obviously this TCP will be part of that data whenever you are talking about the packet. So in the packet the TCP header will be there, and after that one it will be the actual data. But whenever we are talking about the IP packet, we just take this part as an IP header, and all the remaining part will be treated as a data. So that's what we are referring, TCP plus the actual data, but that includes the TCP header. So this is the original IP packet, IP header plus data. Whenever this is happening in the ESP transport mode, so in the transport mode we are having the ESP header as well as the ESP trailer at the end. But the important part is that in the transport mode, that only data is being encrypted. Only this part will be encrypted. That's it. Remaining the AH header and the IP header, that will not be encrypted. It means that whenever this packet will be traveling hop by hop, this IP header will be looked upon, and that packet will be forwarded to the next router. So the main focus is that only data is encapsulated or the encrypted in the transport mode. But when we talk about the tunnel mode, so in the tunnel mode, again we are adding this AH and ESP header, right? This is added at the starting, and ESP trailer will be added at the end, including the authentication, that is also part of in the transport mode. But the difference between them is that this whole thing is being encrypted, right? You see that IP header is also being encrypted in this case. So there IP header was not encrypted, but in the tunnel mode IP header is also being encrypted. So now the question arises that if that IP header will be encrypted, then in the path, whatever the routing decisions will be taken by the routers in between, how they will work upon. So for that purpose we use new IP headers, means that information that is being copied on this field, and this new IP header will be looked upon for forwarding packets from one hop to another hop, or one router to another router. This transport mode is almost never used, and the highly used mode is tunnel mode, and this is the default mode in all the devices. And I can say that 90.99% we are using tunnel mode. We are not using the transport mode. So why we are having this transport mode if we do not use it? This is basically for the legacy devices which are not supporting or having issues running the tunnel mode. For that purpose we are having an option for the transport mode. If the devices in the other vendor or any other legacy devices which are not supporting the tunnel mode, we can opt option for the transport mode. But this is the default mode. If you are not choosing anything for that ESP mode, so by default it will be working as a tunnel mode. Alright guys, now this IPSec is done. We have learned all these things in the IPSec, that what is actually, let me clear it, this negotiation protocols, ESP and AH, and all these things I have covered. Now our focus point will be that how actually the tunnel formation is being done, right? So basically we are going to focus on the VPN architecture. So if I talk about the VPN and the tunnel is being formed, so there are two ways the tunnel can be formed. The first one is routing based, and the another way is policy based. How is basically this routing based and policy based works, that let's say we are having the two routers, right? This R1 here and this is R2, and now we want to form the tunnel between them. So obviously we are having some of the public IP here and the public IP this side in both the routers. Now if we talk about the routing base, so there will be some logical interfaces. Normally they are loopback 0, and other side as well we will be having some logical interfaces, can say as a loopback 0. And now we will be having some routing between this loopback interface through public IP to reach the other loopback interface. So we will be having some routing till the time this other loopback is reachable from here to there or there to here, till the time our tunnel will be up or tunnel will be working. So in short I can say that normally it is always up, it is never down, right? Unless we are having the connectivity broken or any of the devices faulty. So by default all this type of tunnel is always up. And this type of VPN normally we use for the purpose of the OSPF and EIGRP running inside the tunnel, although these are not the used cases and there are alternate options are available, and we can work without using that OSPF and EIGRP. But still, if any enterprises requirement is there and we have to work on that, then we can use the routing based. But this is also the type of thing that is rarely used, and most of the operators choose policy based, not this routing based. Okay, so this is the way, this is the difference between the routing based and the policy based. But now you do not understand the policy based because I have not told you. So now let me tell you what is the policy based. Whenever we talk about the policy based, it means that let's take this scenario once again. So this time what is happening, we are having one network, internal network 10.10.10.0, and this side we are having the 20.20.20.0. And in order to communicate from one side to another side, we are using the public IP address 70 and 80. This is just an example. So in order to form the tunnel, what we are going to do, we are going to set up a rule or policy on this router that I want to make a tunnel for this network. Means that we will set up a rule for the source 10.0 network, 10.10.0 network, or let me write in the short 10 network, and the destination 20 network, because we want to set up the tunnel from 10 to 20 network. So our traffic will be originating from 10 network and the destination will be the 20 network. So we will be having some of the rules here. If there is a firewall, normally this is, I have taken example as a router, but normally most of the times these are the firewall, because routers are not able to handle such type of configuration, or they do not having so much processors or the memory that they can handle such huge traffic. So normally there will be a policy in that firewall, or if it is a router, then there will be policy in the router that for this source and this destination please form the tunnel. So this type of thing is called as our interesting traffic. Why we call it as interesting traffic? Because we are quite interested to form tunnel for this network 10.10.10.0. Same thing we are going to do on the other side. We will be having some of the policies mentioning that this is my source address and the destination address 10.10.10.0. So this is the basically mean by the route based and the policy based. Now if the interesting traffic, now our first part is done, that we have defined our interesting traffic now, right? So once our interesting traffic is done, so now this is turned for forming the phase 1. So how the phase 1 means that whatever we have just covered up that is basically taking the help of ISA-KMP protocol. And this IKE, this is like internet, the full form of this internet key exchange. So this is we can say the the governing body, whatever the negotiation and all the things will be happening, that will be happening under the monitoring of the IKE, internet key exchange, and this will be taking the help of ISA-KMP protocol. We call it as an ISA-KMP, and the full form is Internet Security Association Key Management Protocol. So for the setting up of a purpose of our phase 1, IKE takes help of ISA-KMP protocol, and normally it uses our UDP port 500 and 4500. So some of the times it uses the 500 and some of the times it uses 4500. So I will just come up later on that when it uses the UDP port number 500 and when it takes the help of port number 4500. But as of now, it takes the help of ISA-KMP, and we can say that it uses the Diffie-Hellman key. This is a phase 1, or we can say the asymmetric algorithm. Right, so this is going to happen in the phase 1. So if I talk about the protocols, what we just set up, not protocols, in fact the parameters in order to exchange these Diffie-Hellman key, or we can say the asymmetric algorithm or the IKE phase 1, all refer to the same thing here. We can say the IKE phase 1 or the phase 1 tunnel, or we can say the Diffie-Hellman key exchange, or we can say the asymmetric algorithm. So these all refer to the same thing, and whenever it is happening, it is having some of the parameters for everything. Like encryption, we have to set up that what encryption parameters you want to set up. So for the encryption, let's say I have taken that AES 128, right? So this is the configuration that I want to encrypt the data using AES 128. And for the authentication, I can use the PSK, pre-shared key, and one more thing, it was hashing, and for the hashing we can use like MD5. So these all parameters are being configured whenever or the negotiated during these IKE phase 1 setup, these all parameters. Once all these parameters are negotiated from end A, right, let's say this is one firewall here and another firewall this side here. Let me change the color as well now. 2 should be fine, I think. Oh, this is, let's take 3. Yeah, pink one is okay. So let's say this is our firewall, right? And here also, let's say we are having a firewall, and now they have set up our IKE phase 1 tunnel based on the negotiating these parameters with the help of ISA-KMP protocol. Once our IKE phase 1 is being set up, it means that we are having our both the sides, our DH key, Diffie-Hellman key, is being generated, or it has generated. If the phase 1 is up, it means that the DH key has been generated on both the sides. Here also we can say the DH key is generated. So now we are having this tunnel inside of that one. Now we are going to exchange our shared secret key. Now it's time of phase 2, right? Once our phase 1 is basically providing an encryption environment to share our shared secret key, right? That's what we discussed in the previous class. The same thing we are discussing the actually what is happening in terms of the IKE phase 1 and phase 2. When it comes to the IKE phase 2, IKE phase 2 takes the help of IPSec ESP. Now ESP, what it is going to do, obviously it will it will use, normally it uses our tunnel mode. It will be using our tunnel mode, and the shared secret key will be exchanged. Correct? Here point to be noted, or just keep in mind, for the encryption and decryption there are two instances. If you talk about, you see that there is a one tunnel for the IK phase 2 here and another IK phase 2 here, and from this instance we are going encryption. It means that whatever data is going from here, it will be decrypted on this side, and whatever the data is inserted here, that will be decrypted on this side. It means that we are having two instances for encryption and decryption. It is not like that one, the same thing will be same instance will be doing both the things. So there will be separate instances for the encryption and decryption. Means whatever the data will be going for being encrypted here, that will be decrypted here, and vice versa for the another one. Correct? So that's why we have mentioned that phase 1 are bidirectional, that it can work in both the ways, here as well like this one, while the phase 2 are unidirectional. Means that whatever goes here encrypted, that is decrypted here, and whatever goes encryption like this one, that will be decrypted like this one. So these are the unidirectional. So now our phase 1 is set up and phase 2 is set up. Phase 1 is set up using ISACM, DH keys, Diffie-Hellman key, and using sharing the public keys, and the Diffie-Hellman key got generated. Once the Diffie-Hellman key got generated and we got an encrypted tunnel, then we shared our shared secret key, that is SSK, and after sharing that SSK, our encryption and decryption has been started, and that we call it as a data transfer. Now next thing comes to our VPN tear down, that if the tunnel is set up and it has been set up, then how long this will be valid. So by default, what is happening for the phase 1, the time is 24 hours. These are the default timers, and most of the vendors follow these one, and even enterprise don't want to manipulate these things. So for the phase 1, this is 24 hours, or we can say the Diffie-Hellman key, that is valid for the 24 hours. And for SSK, we can say the shared secret key, which is for the phase 2, that is valid for 1 hour. Means that after every 1 hour, new shared secret key SSK will be shared from here to there, right? So every time, every 1 hour. So it is not like that one, that in between there will be a traffic outage, or we can say the packet drops. Whenever the timer is about to expire, by default or automatically the new key is negotiated and there is no outage in between. So 24 hours for Diffie-Hellman key and SSK for 1 hour, right? So how many shared secret key will be in 24 hours? Obviously these will be 24 SSK. So sometimes interviewer ask this type of questions, that whenever the phase 1 tunnel is set up and phase 1 is running fine, then how many shared secret keys will be shared during that time? So if this is 24 hours and every hour one key or one SSK is being shared, then obviously 24 SSK will be shared during the tunnel is being set up. And once these 24 hours has been completed, then again the new Diffie-Hellman key will be generated. There also there will not be a traffic hampering, that there is an outage. This is automatically negotiated and generated, and they handshake with each other and the traffic is being working. right? Any questions on this one, because this is quite complicated, but how you are going to ask the question, the problem is that. So no ways, just if you have any questions, just reach me, or you can write in the comment, I will get back to you. Or if you are in the any of the channels or other modes of the communication, you can reach me, right? Or you can just join my video, live sessions. There we can discuss these type of doubts. So that's okay. Now let us try to understand how or what of the messages are being sent whenever we are setting up IKE phase 1. Let's see those things. Let me go to the next slide. Yeah, here it is. Perfect. These slides really help me to demonstrate you, otherwise I just keep drawing these, so that becomes very difficult. Sometimes picture help me to demonstrate well, otherwise I'll be keep drawing and my drawing will be so bad and you guys will be confused at what actually I'm drawing, and it takes time as well, right? So I just save the time by doing this one. So this is like we are having a firewall here or the router. Let's say one of the firewall here and one of the firewall here, and now it's time for them to set up the tunnel. So the first message, there are two ways the phase 1 can be set up. The first mode is main mode, and another way is aggressive mode. So let's discuss one by one. Let's talk about the main mode first. So in the main mode, we are having the 6 messages. We call it as the main mode message 1, main mode message 2, main mode message 3, 4, 5 and 6. The first message is being initiated like this. IPSec protocol tries to send an SA payload. As here SA stand for the Security Association, a little fancy name, but the parameters what it includes, like what encryption method we are going to use, like AES 128 or DES, right? So this information, what are the hashing technique we are going to use, what is the PSK or authentication method we are going to use. These things are being sent from here to there, from left to right, from this message to this message, and in reply, in main mode message 2, the router 2 will send these information back to this firewall or the router. So this is basically, we call it as a IKE SA negotiation, that if I have configured these parameters on my machine or this firewall, what are you having? If these parameters match, then only the phase 1 tunnel comes up. If there is a mismatch, here you have configured AES 128 and other side you have configured the DES, obviously the phase 1 will not come up. Or if you have some another password here, there's some other password, then also the phase 1 will not come up. But this PSK things come here, piece authentication. So basically this is like I say AES 128 and MD5. These two things are, or in fact the parameters are being negotiated here, right? The PSK comes at the piece authentication. Once this SA negotiation is being done and they satisfied that okay, both the sides we are having the same parameters, then it's done the key exchange. We call it as a key, and like what it will do, it will share the public key. Diffie-Hellman exchange. So in the Diffie-Hellman exchange, what it does, it shares its public key, and once it shares the public key, the DH key will be generated on both the side with the help of their own private key. Here also we are having DH key, here also we are having the DH key. Both the side DH key is being generated. It means that we are set up with the tunnel. we have set up the tunnel, but still we have to verify that whatever the tunnel we have set up, is that guy authenticated or not. So for that purpose we do the peers authentication. We check that whatever the password configured on this side is configured on the other side or not. So you see that PSK. So here it's just check that authentication method is PSK or not. Is checks. Okay, here also we are having PSK, here also we are having the PSK, but the actual password, that what is the password here and what is the password there, that is being checked in this peers authentication, or in fact we can say the MM5 and MM6. Now here it's a very important question, and I'm sure that most of you guys will not be aware. So I'm really creating a curious environment that you should, if you are not listening all those things very carefully, then just focus whatever I'm just going to tell, that is really helpful. How actually, or let me ask the question like that, I know, very general question, not related to this VPN. Let me clear this. Let us say we are having these two routers, just very simple example, right? If let us suppose you have set up the password here as Cisco 123, here also you have configured the password as Cisco 123. Now how these devices will come to know you are a person standing here, you can easily come to know, okay, you have configured the password as Cisco 123 and if they are matching or not. But how the machines will come to know? And if you say right, that Cisco 123, if by chance if you think of that one, right, that this password will be shared to each other. So by default, if it comes in your mind and if you share this password to this guy, that my password is Cisco 123, then this guy will be listening that communication and it will easily come to know, okay, that person has sent the password as Cisco 123. Now if I have known it, then obviously I will set up this password on my machine and I will negotiate with that one. Or let me just take a simple example. Let us suppose there is a Wi-Fi of your neighbor, right? Obviously in the homes there is a Wi-Fi and you want to use his Wi-Fi, he's broadcasting, and you are having a mobile. Now if that if that machine shares its own password with you, then obviously you will set that password in your mobile phone and you will be able to communicate, right? So actually how these passwords are being sent to other device, that it knows the password, it can verify it, but still it does not share the password. Little confusing, right? Even without sharing the password, it just cross verify that it is the same password configured on other side or not. How this is being done? This is being done with the help of hash. So this is the method we normally use it in all the purpose, but I'm sure that you might not be aware of this thing. So it takes the help of hash. Means let's suppose you have set up the password as Cisco 123 here. What it's going to do is it will pass this password in the hash function. It will create some hash, some random, not random in fact, the hash of that one, like 1223SD5, right? Sometimes it is these what is called I forgot the name, what you called not variables, what is it, dollar, right? Alpha, not alpha anyway, guys, these characters, right? I just symbols, what we call it as this ampersand, star, asterisk. So these things that's what is not coming in my mind. So sometimes these things are generated based on this password, means that our password will be passed through our hash function and it will create a hash for that value, right? 23895 something, and this hash is being shared to the other side. What other side will do? Other side will pass this their password. Let's say they are having also the password as Cisco123. They will pass this to the hash function. If the output of this hash function and output of this hash function is matching, if they are same, it means that the password is matched. Means that you have not shared the actual password, you have shared the hash of that one. And I tell you that it is really impossible to do reverse engineering from here to there. You cannot. It's almost impossible, because these are normally 256 bits, or in fact, you know, earlier what was happening, like some of the times also people used to say that MD5 is not secure anymore, because some of the time this can be guessed, but still it is treated as a secure. I do not say that this is not secure, but some of the people say that MD5 is not much secure. Some of the time we used to do reverse engineering and recover the password, but that is a different story, that we can recover it or not. But the normally, in fact I should say normally, we cannot do the reverse engineering and recover the password. Even if you can say that it is recovered, there's another option, SHA, and these are available easily. SHA-512 and 256. So they are highly, you know, almost, I will never say that impossible, but almost impossible. Obviously that is totally dependent on the computing of our computers, that how fast they calculate and how fast they break the password. But in today's environment, or till today, it is totally safe, and nobody can do reverse engineering and break the password. In future, after 50 years or 100 years, so there might be some technology available and we can break these password. And if we will be able to do reverse engineering or break these things, then obviously some other algorithm or the techniques will be available which cannot be broken. So as of now, we cannot do reverse engineering, and this password are always shared in the terms of hash, and that's how we do the matching of our password. So I was just little deviated from our topic. Our topic was how the main mode matches, right? So that's how it is done. So in the MM1 and MM2, the IKE-SN negotiation is being done. In MM3 and MM4, Diffie-Hellman exchange, DH key is being generated. MM5 and MM6, piece authentication using the hash. So they are sharing their hash with each other, and they will cross verify that if their hash is matching or not. If their hash is matching, their we have set up the tunnel with the right guy. Some of the time I have observed there was one question, that why we do not set up this authentication first and then we do the Diffie-Hellman exchange, right? I just remember that if I said this is the 1, 2, 3, this is how it is happening, and one of the question it was that if why it should not be like 1, 3, 2. It means that first we should check that what is the password, and then we should share the public key. While we set up the public key, share the public key first, and then we check the peer's authentication. Why we are not doing that? Because once you share the Diffie-Hellman key, you set up a tunnel, right? A tunnel is being set up. So now if you are sharing your hash, that sharing of hash is also being encrypted, and that is traveling through the encrypted tunnel. So that's why we prefer it this way. First we share it the Diffie-Hellman exchange, and then we go for the peer's authentication. And it can happen that sometimes you have shared the public key with the wrong guy, so your hash will not be matching, so you will stop communicating with other guy, and whatever the public key you have exchanged, that not valid more, that does not work because you did not finish setting up your phase 1. Another mode was aggressive mode. So aggressive mode is, we call it as the less secure. We can say it as less secure because here what is happening, this SA payload and this key, or in fact the Diffie-Hellman key, these are shared together. We can say that this is going to be our first message, and in the second message we are going to do this hash, and third, if we get the reply back, or we can say in the third one we can just get the reply as a negotiation altogether. So then based on these parameters matching, we are setting up the aggressive mode. Why it is not being secured? Because this is not going step by step, even without being the encryption, and although all the parameters are checked, but all the messages are going all together. So because of that one, we call it as an aggressive mode is not a safe, when the main mode is going step by step. If any of the things is not matching, the phase 1 setup is being stopped immediately. So this is the difference between the main mode and the aggressive mode. Now our phase 1 has come up. Now it's turn to check our phase 2. What are the things we are going to check in the phase 2? In phase 2, the first thing, it negotiates the IPSec SA parameters protected by an existing IKE SA. So our tunnel has been set up. Now it's time to negotiate our SSK, shared secret key, right? Because we are having a tunnel, and inside that tunnel encryption method, we will share the secret key from this side to other side. Once the shared secret key has been set up, it establishes the IPSec security associations, and obviously the phase 2 will be periodically negotiating the IPSec SAs to ensure the security. So we know it that every 1 hour the SSK is being changed, and new shared secret key will be shared from one end to another end. Right? So we can say that one Diffie-Hellman key, that is valid for 24 hours, and that consists of 24 shared secret key. 1 DH, 24 SSK, because the time period of Diffie-Hellman is 24 hours, and for the SSK it is 1 hour, right? So for the one Diffie-Hellman exchange, there will be 24 shared secret key exchange. Sometimes there is a requirement, or we need highly encrypted environment. It can be a financial institutions or the banks, where they need more security. So for that one, there's things comes in the picture that is called PFS. Very important terms, and 90% interviewer asks this thing, that what is this PFS? PFS stands for the perfect forward secrecy. Very important term, but very easy. This is perfect forward secrecy. What is happening this time, that we set up phase 1 tunnel, 1 DH key, right? And after that one, what was happening, that every hour we used to share the shared secret key. What happening in the PSK, after phase 1 tunnel is set up, our phase 1 has come up, we are having the phase 1, and even in the phase 2 we are using one more Diffie-Hellman key. Means that whatever the SSK was going to share, we are sharing one more DH with the other side, and then we are sharing the shared secret key with the peer. So it's like that one. Earlier how it was? Earlier it was like this, that we are having one DH, and inside that one DH we used to share the shared secret key. But this time we are having one DH, and inside that one Diffie-Hellman key every 1 hour again we are sending the Diffie-Hellman key that will be authenticated, and inside that Diffie-Hellman then we are sharing the shared secret key. So this is the difference between the PFS and the normal phase 2. So here we can have 1 DH Diffie-Hellman, 24 Diffie-Hellman key, and inside that one 24 SSK. Means that every 1 hour we are sharing the Diffie-Hellman key as well as the shared secret key. Clear, guys? I think you are a little confused. If you are a little confused, you can watch it once again, and questions are always welcome. Right? Not to worry. So that's how this is IKE phase 2 is being set up, and obviously inside this SSK we are having the data. So this is the more secure. That's why we call it as the perfect forward secrecy. Okay, now this is the term for the I remember you guys that I said that I will discuss that when we use the port number 500 and when we use the UDP port number 4500. So the difference is like that, or let me take an hypothetical scenario. Let us say you go in interview, and interviewer asks you that you are having the 2 firewalls. This is not looks like firewall. Let's say this is the one firewall, and another one you have like this, and there's a internet service provider in between, and by chance now interviewer service provider asks you that which of the protocols you want allow us. Normally such type of questions are not being asked to service provider because everything is allowed via service provider. But if anyhow, if you for the interview point of view, if anyone asks, what are you going to answer? So the first thing, what protocols? That first thing you will allow ESP, IPSec, and for the IPSec we are going to allow UDP port number 500. Perfect. Another question, whenever you say this answer to the interviewer, the next question comes that if you have enabled the NAT. If you have enabled NAT. So if you enable the NAT, so obviously these things will be the same, but the UDP port number in case of the NAT, if the NAT is enabled, the UDP will be communicating using port number 4500. You don't have to do anything, you don't have to configure anything on that one. This is by default. This communication happens that whenever you initiate the communication, it is generating a message for the NAT discovery, and if in between the NAT is running, it is using UDP 4500. You don't have to configure anything that it should be using port number 4500 or 4500. But yeah, by chance if any of the firewall is coming in between, and if NAT is enabled and you have just allowed only port number 500 for that purpose, so the VPN tunnel will not be coming up because it will be trying to communicate with using the port number 4500, and your fire will be blocking that port number. So that may happen. So that's why it should be known to you that in which cases it uses the port number 500 and in which case it uses the port number 4500. So this is the only difference between the UDP port number, and it just totally depends that whether you are using the NAT T or you are not using the NAT traversal. T stands for the traversal. Alright guys, so that is quite okay here, and I think it is time to do the practical lab. Let's do it or configure in our checkpoint. But I think before that one, let's just go for the some of the interview questions, that how interviewer asks you that what you should do and what you should not do, something like that one, because that is very important. What is this color? Blue. So the first and genuine question by the interviewer, and it is good to know by you as well if you are in the troubleshooting environment. But the first question interviewer asks that if your phase 1 not coming up, what are you going to do? So what is coming in your mind? Obviously what we have discussed right now. What were the parameters it was negotiating? The first thing, the parameters, right? SA negotiation. You remember the messages, main mode 1, it was doing the SO negotiation. So obviously the SA parameters should be matching from left hand side to right hand side, or both the ends, they should be matching. Another thing, and yeah, very important, the reachability. What if the firewall is not reachable, right? This from A end to B end, reachability we are not having. We are having any breakdown, or the default route is not available, or anything, it can be happen, right? So very important. In fact, the reachability should be the first one, that it should be the reachable. Then you can check the SA parameters. What else it can be? It can be having the wrong password or something, right? So the PSK, I think that comes under the SA parameters. So that is okay, and I think that's okay. And yeah, the traffic, interesting traffic we can say, because if the interesting traffic is not there, so it will not try to set up the firewall, right? It will not it will not create establishing the tunnel. So let's say that phase 1 is up and phase 2 is not coming up. If the phase 2 is not coming up, what you are going to check? Think of, yeah, just memorize what we have just discussed. Obviously the questions are hidden what we have just discussed. So the first thing will be the routing. Just see that whether you are having the proper routing for that purpose, means the traffic is going, or we can say the interesting traffic is clearly, policies are set up or not. What else can be? DH keys are okay, and so these two things we can check. Another thing, that phase 1 and phase 2 both are up, but still it's like we can say that we are having the two instances, right? One for encryption like this one, and another one like that, means like this encryption here, decryption here, and for the second instance encryption here, decryption here. So let's say this is site A and this is site B. So it's like at the site A, it is encrypting the traffic but not decrypting the traffic. Not decrypting the traffic, it means that the traffic is not coming this way, right? This can be the scenario. So for that one, what you are going to check? You are going to check the traffic or the interesting traffic at site B. So these are the interview questions, and they always ask. I think if you such type of questions, they will be just asking like phase 2 is not coming up, what you are going to do, or this type. This is very important. I think I have given interviews and they asked me 2 to 3 times these things. They directly just skip this part. They just ask me that it is encapsulating but not decapsulating, or it is discapsulating and not encapsulating. And another thing, you can check off the NAT. If there is something in between the NAT is doing, here also you can check the NAT, if something is NAT is happening in between or not. right? Sometimes because of the NAT, your interesting traffic is not coming up what you are expecting, right? Your source you have set as 10 to 20, but it is doing NAT in between and it is going to something 15 to 20, and as a result your traffic is not coming up or is not encapsulating and decapsulating these 10 networks. So what I'm saying about 10 to 20 means that 10.0.0 network, or it can say, you know, something between that, whatever you have defined in your network, that it should be that this source to this destination, but because of the NAT it has been changed to some other IP addresses, and because of that your tunnel is not coming up. And that's okay. And yeah, sometimes they ask that if your VPN is fluctuating, then what you are going to do. So for the VPN fluctuations, you can check the first the ISP connectivity, or you can say the reachability, right? You can check the delay, and that what is the time delay from the A end to B end, and what else, we can check the timer values, tear down, right? Tear down timers, right? We just said that they are the 24 hours and the 1 hour. So theoretically there should not be any issue, because we have just discussed there should not be any traffic outage. But sometimes because of these small values, if we have somebody has messed up with these, sometimes like anybody has changed set up the 8 for the phase 1 8 hours, and for the phase 2 they have set up as 12 hours, right? So there sometimes it is happening. So you have to check that whether these timer values has been changed. So because of that they might create some of the drop of the packets, so that we can check of those things. So these are the things we can check as an interview, or the questions you can discuss. And obviously they, in the real environment you never know what interviewer is going to ask. So but yeah, these are the commonly asked questions, and 90% or in fact 95% interviewers ask these questions, and or they can go little deep in any of these topics. That's it. All right guys, I think this is sufficient for this one. This is already 1 hour, so that's okay. Let me stop it right now, and in the next session I will just take a lab of this checkpoint firewall, because till the time what we have just discussed was generic for all of the vendors. But now we are because this is a course for the firewalls, so not firewalls, in fact checkpoint firewall. So I will just discuss totally focused on the checkpoint firewall, that how the tunnel is being configured, or the IPSec tunnel is being configured in the checkpoint firewall, and what are the things required for that one. Okay guys, till that, bye bye, see you soon. And yeah, if you have any other questions, please reach me anytime. I will be happy to help you for any of the questions. You can join my live session. I'll be really happy to help you for that. Thank you guys, bye bye, see you soon.